Welcome back. In today's video, we would like to write a Python program to create a class representing a circle. And we would like to include methods to calculate its area and perimeter. So here is my class called circle. We see that we are having two methods, or let's say functions here, and we are having a constructor here. Okay, so this is my constructor. How do I know that it's my constructor? Because we are having underscore underscore init underscore underscore. So double underscore init and then the double underscore again. So this is how I understand that I'm having a constructor. And now that I have a class that has actually a constructor, we can understand that whenever I create an object from this class, the constructor is automatically activated. And when it is automatically activated, we know that when we create an object of this class and we are having a constructor, and if there is an argument for the constructor, we need to have that argument when creating the object. I will explain this in a few minutes. Apart from the constructor in the circle class, we are having two functions. One is called area, the other one is called perimeter. So the area function is going to calculate the area of a circle for us. So we are going to have pi multiplied by radius to the power of 2. So star star means to the power. So radius to the power of 2. And this pi is using this number, so 3.14. We can either call the math library to access the pi number, or we can simply write down 3.14 instead of this. Okay, so in order to use the pi number from the math library, just remember that you need to include the math in the header of the program. So this area function is going to calculate the area of a circle, pi multiplied by radius to the power of 2. So all we can say radius to the power of 2 multiplied by pi. Then we are having a function called perimeter. So this function is going to calculate the perimeter of the circle for us. And the formula is this: 2 multiplied by pi multiplied by radius. This is the standard formula for calculating the perimeter. So now in this code exercise, when we run the code, it asks me to enter the radius of a circle. When I enter 5, it is going to make the calculation for the area and also make the calculation for the perimeter. But how can it work like that? First of all, we are showing this message: enter the radius of the circle. So exactly this message: enter the radius of the circle. So we are making an interactive program with the user. We are asking the user, okay, enter the radius that you want to have for your circle. Then I'm going to calculate the area and the perimeter for it. And we are using the input function to show this message. And whenever we are showing this message, whatever the user is going to enter, we are going to store it by default in Python as a string. Okay, so when we are using the input function to get anything from the user, by default, it's a string. And now, because we would like to work with the calculation of the area and perimeter, we need an actual number, for example, a float number. So this is why we are having the float keyword here. So whatever that is whatever that we are getting from the user, we are using the input function to store it. It's a string. We are using the float function to convert it to a float, and then we are assigning it to radius. This is my variable. Now that my variable is having the radius that I would like to enter, for example, I entered number 5, so radius equals 5. Now I would like to create an object of the circle class to access the area function and the perimeter function. How can I do that? So first of all, in order to create an object, we need to choose a name for it. So I choose the name to be C. That's it, capital C. This is the name of my object. It can be anything. It can be my object. It can be hello world. It can be whatever that we want. It's not important. The name is your choice. So I'm choosing it to be C. C equals, then circle the name of the class, and we are having one parameter here. Why do we have this parameter? Because we're having a constructor, and apart from self, my constructor is requiring a parameter. Okay, and we mentioned that when we are creating an object of this class, because we are having a constructor is going to be called automatically. Therefore, when we are initializing the object, we need to have the radius here. So I'm creating an object from the circle class that is called C, and as the argument, I'm having the radius that we stored the input by the user. So when I create the object, the constructor is automatically called, and this radius is passed as argument. And this radius that we passed as argument is assigned to the attribute of this class. Okay, so this is a self.radius. So we are storing the parameter here using the constructor. We are initializing the radius. Okay, so this is how I created the object, and automatically the constructor is called. Then, in order to call the area and perimeter function to do the calculation for us, now we are having the radius. I can use the object C from this class, because through the object of the class circle, I am able to access the area function and perimeter function. Why? Because this is an object of the circle class, so give me access to all the functions in this class. And you see that in area and perimeter functions, we have no arguments apart from self, so I don't need any argument to call these two functions. So I use the print function to print the output. Simply, I write down the area, so the area, this message. Then I use the object C, then I put a dot, and I call the name of the function, which is area. So basically, it's like that, C dot, the name of the function, which is area, and that's it. The rest, when I have the colon dot to F, means that I want to have only 2 decimals. Okay, this is what it means. I would like to have only 2 decimals, an output of 2 decimals. So I'm going to call the area function with using the object C, and I want to have only 2 decimals in the print here in the output. Okay, when I'm printing the stuff in the output in the terminal, I would like to have it only to be with 2 decimals, and as you see, it's with 2 decimals. If I make it with 3 decimals, it can go up to 3 decimals if there is any decimal there for the third part. So now the area function is called. This area function is going to calculate this formula for me, radius I have, because I got it from the user, and I store it in radius, and I created the object. So the parameter is stored in the attribute of the class circle. So self.radius is holding my radius. So now I call the area function. The pi number is imported from the math library. We are multiplying it by the radius, which is the attribute that we just initialized using the constructor, to the power of 2, and the output of this is multiplied by pi number, and this function basically is going to return the area of the circle for us, and only up to 2 decimals of this area is being printed in the output, because we are having colon point or colon dot 2f. Okay, then I'm having the print function again here, and I write down perimeter. Then I use the object called C that we created, an object of the circle class. So I use that object to call the perimeter function this time. So C.perimeter, the name of the function, an empty parenthesis. So this function is called, I'm calculating 2 multiplied by the pi number, multiplied by the radius that we stored using the constructor. Okay, we passed this parameter to the constructor, and this was assigned to self.radius, and self.radius is being used here. And we are going to have the colon dot 2f, so it means that we are going to have up to 2 decimals being printed in the output. Okay, so this is the output that we see here. So area is calculated and perimeter is calculated here again. So when I run the code, again, it asks me to enter the radius. I write down 5. It does the calculation for me for the area and perimeter. So I run the code. This time I say the radius is 13. Now here is the area. Here is the perimeter. I write down, for example, 2.5 as the radius. Accordingly, it is going to calculate the area and the perimeter for us. So this is how we can write a Python program to create a class representing a circle and include functions to calculate the area and perimeter of a circle. Thank you for watching. Welcome back. In today's video, we are going to write a Python program to create a class called person and includes attributes like name and country. So we are having a class called person and it has a constructor here. This constructor is basically going to it's going to be called automatically when we are creating an object of the person class. So this is my constructor. Apart from self, it needs two arguments, name and country. Whenever we are creating an object, we need to know that we are going to have two arguments to be passed to be initialized using our constructor to our public attributes of the class name and country. So let me illustrate it with an example. It says name and input. So we are going to ask the user enter your name. Using the input function, we are going to store it in the name variable. Name is a string holding the name of the, for example, user. Then we are asking the user to enter your country. Whatever the user is going to enter, it is going to be stored in the country. Then I am creating an object called person from the person class. I can rename it to put it P, for example, here. It would be easier to understand. Oops, sorry. So now I'm creating an object called P from the person class. And here I am passing two arguments that in which we stored the name and country that we got from the user. When this object is created, the constructor is automatically called and it is going to initialize the name to my self.name attribute and the country to the self.country attribute. Okay? So whenever this object is created, the constructor is going to initialize these two attributes. And we can also have a message being shown here. For example, we can have print the constructor is called. Okay, so we know that the constructor is called. Then after having the object, we can use the object to access the attributes that we stored in the person class. How? So I use the object, which is p dot name, the name of the variable, and dot then another name of variable, which is country, to access the information that we stored here using the constructor. So when I run the code, it says enter your name. For example, I write down Reza. It says enter your country. I would say in Canada. Then it says the constructor is called. So this is the automatic message because we are building the object. We are creating the object. The constructor is called and Reza is assigned to the self.name, which is our attribute. Then Canada is also assigned to the self.country, which is another attribute of this class. These are the public attributes. Then we are using the same object to access the name and country attributes. Okay, so name and country attributes. So you see that Reza from Canada is being printed using this print function. We are printing Reza from Canada, but using that object, we accessed the attributes of that class called person. So in this coding exercise, we learned that we can create an object of a class that has a constructor with two arguments. And whenever the object is created, these two arguments must be passed. Okay, must be passed. And these two arguments are used to initialize our attributes. And then using the same object, we can access the name and the country. For example, here I'm going to create another object that is called P2. I'm saying person, then name, and for example, I would say name and country, but this time I would like to get another name. So name is now Shaheen, for example. It is Shaheen. And country is, for example, United States of America. So it's USA. Okay. So this is now I call it name 2 and country 2. So name 2 and country 2. So now that I use these two parameters, when I use these two parameters to pass as arguments when creating the second object, the constructor is again called. This time it is initializing this name and this country. So Shaheen, USA. So Shaheen is assigned to the attribute of the class. USA is assigned to the attribute of the class. Then this print is being printed out in the output. This message, the constructor is called. And then I can have this being here, for example. This time I would like to have P2, name2, P2, and country2. So when I run the code, it says enter your name. I would say Reza. Enter your country. This is Canada, for example. And here we are having an error. So what is the error that we are having here, for example? Here it says, okay, so here there was a problem because I was writing down the name of my parameter, not the attributes of the class. Okay, here we should write down the attribute of the class, which is name, and then the attribute of the class, which is here country, and not country2 and name2. Name2 and country2 were the parameter that we used here. So we see in the output, it says the constructor is called Shaheen from USA. So let me go through it one more time from the beginning. We are having a class called person. We are having a constructor with two arguments. So whenever we create an object of this class, the constructor is automatically called and two arguments must be passed. These two arguments are assigned to the attributes of our class. And this message is being printed. The constructor is called. Then we are asking the user to enter your name, enter your country. These two are information that we get from the user, and we're going to store them in variable called name and variable called country. Then we create an object of the person class. This is the first object, and pass the name and country. Why we pass them? Because we have a constructor, it requires two arguments. And then the name and the country is assigned to the attributes of the class. Okay, and this message is shown, constructor is called. Then we access, using the object that we just created, we can access the name and the country that we just stored information in that. Okay, and here we are printing the information. So we see that it says enter your name, this message, enter your country. So I say Reza, Canada, and it says the constructor is called because we are creating an object passing these two arguments. The constructor is called, this is the message, and the variables are initialized. Then after that, it says Reza from Canada. So this part is being shown here. So we use the object name, which is P, and then the name of the attributes of the class, which is name and country. Okay. Then I'm having two more variables, name2 and country2. So in name2 is Shaheen, the country2 is USA. Then I create another object which is called P2 from the person class, and I pass two arguments this time with the second object, name2 and country2. These two are passed to the constructor, so name2 is assigned to the attribute, and country2 is assigned to this attribute as well. Okay, so this is how. So in order to access the name Shaheen and the country USA, because we pass them using the second object, we need to use the same object, then dot the name of the attribute, which is name, and the name of the other attribute, which is country. And using the print function, we're printing it out. So we see that it says Shaheen from USA. So we use the first object to store the information about Reza and Canada. We use the second object to store information about Shaheen and USA. Okay. So whenever I would like to have access to Shaheen and USA, I need to use my second object. Whenever I would like to have access to Reza and Canada, I must use the first object. Okay, because using that object, we store the information in the attributes of the class. I need to always keep that in mind that if you want to access to the Reza Canada, you must use the first object because you used the first object to initialize them through the constructor. This is the important point of this coding exercise. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to create a calculator class. And we would like to include some methods, or let's say functions, for basic arithmetic operations. So here is my class called calculator. And here we see that I have 4 methods, or let's say 4 functions. The first function is called add. And apart from self, it has 2 arguments. And basically this add function, whenever it is called, we need to have 2 arguments when we call the add function. And this function is going to return a plus b. Then we are having the second function called subtract. And we are having, again, 2 arguments when we are calling this function. Basically, this function is going to do a minus b, the calculation, and return its result for us. Then we are having the multiply function. It is going to return the a multiplied by b, and we are having the divide function, which is going to return a divided by b. And if by chance, b equals 0, which is the second number, so a is divided by b. If b equals 0, we need to return this error because division by 0 it's not possible, and return this error. So if b equals 0, this error, a message is shown. If b is not equal to 0, we're going to have a multiplied by b. Okay, this is the overall idea of my calculator class. So 4 functions: add, subtract, multiply, and divide. Then we are here creating an object called cal from the calculator class. And because we have no constructor, we have no argument also in parentheses while creating the object. So this is the object that I create from the calculator class. And using this object, I should be able to access these functions. Okay. Now I'm having 2 variables here. Variable 1, which is called num1, is assigned number 10. And variable 2, which is called num2, and it is assigned number 2. So this is the overview of what's happening here. Now I would like to use the object cal to access different functions like add, subtract, multiply, and divide from the calculator class. In order to do that, here I'm having the print function. I'm printing this message, for example, addition, subtraction, multiplication, and division. Okay. Then I use this cal object to access the add function, the subtract function, multiply function, and divide function. And you see that in parentheses, I am passing 2 arguments. Why? Because we needed 2 arguments, a and b, for calling these functions. So whenever I call one of these functions, I must have 2 arguments. And these 2 arguments are num1 and num2, So I use the cal object to call different functions of that class, and every time I'm passing num1 and num2 as the arguments for these functions. So first of all, we're calling the add function with 10 and 2, which is num1 and 2. So basically it is going to return 10 plus 2. So addition 10 plus 2 is 12 is printed. Then we are having the subtract here, num1 and num2. So 10 minus 2, which is a, is 10, b is 2. Why? Because num1 is 10 and num2, the second argument, is 2. So here the first argument is a and the second argument is b apart from self. So 10 minus 2, the output is subtraction, is 8. Then we are having the multiply function, which is called here with 10 and 2. So it will be 10 multiplied by 2. It will be 20. And finally, we are having the division, which is here a multiplied by b, and 10 multiplied by 2 is 5. So this class calculator is having some relevant functions inside of it. And then using an object created from the calculator class, we can access different functions of that class and call them using different arguments and variables. So for example, if I change the number from 2 to 0, we should have an error for the divide part. Let me run the code. You see, we have 10 by 0, the addition is 10, the subtraction is 10, because 10 minus 0, it's 10, 10 plus 10, 10 plus 0, it's 10. Multiplication, 10 multiplied by 0, so it's 0. Then we are having the division, so there is an error here, error, division by 0. Why? Because 10 cannot be multiplied by 0. And why this message is shown? Because the second argument, apart from self, the second argument, which is b equals 0, and here we are checking if b equals 0, return this error message, error, division by 0. So this is why this is happening there. And also, for example, if I write down 20 and here I write down, for example, 10, we can have the new results here. You see 30, 10, 200, and 2. So 200 comes from the 20 multiplied by 10. Basically, in this video, we learned that we can create a class, and inside that class, we can have the relevant functions. And we are calling these functions using the object that we created from the class. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to create a class that represents a shape. And it includes methods to calculate its area and perimeter. And we are going to implement subclasses for different shapes like a circle, triangle, and a square. So here, first of all, we are importing the math library because we are going to use it when calculating the area of a circle, because we need the pi number 3.14. We can simply write down 3.14 here, or we can use the pi from the math library. So we import the math library first of all. Then we are having a class called shape. Here I'm having two functions, area and perimeter. Then we are having a class called circle, which is based on the shape class, so it inherits from the shape class. It has a constructor, so whenever we are creating an object of the circle class, the constructor will automatically activated and called, and we need to pass one argument when we are creating an object of this class. And basically, this constructor is going to initialize my attribute of the class, which is self/radius. Then, continuing with the circle class, we are having a function called area, and we are having the pi multiplied by radius to the power of 2. So radius to the power of 2 is multiplied by pi number to calculate the area of a circle for us. Then we are having another function called perimeter, and this function is going to calculate the perimeter of a circle for us based on the radius that we are going to give to the compiler when calling this function. And basically in the perimeter function, we are having this formula 2 multiplied by pi multiplied by radius. The radius is the number that we are passing as argument when creating an object of the circle class. So the constructor will be automatically called, and that number is assigned to our attribute of the class. So we see that that is used here, multiplied by pi multiplied by 2. We are going to have some numerical examples to have a better understanding of this. Then we are having a class called square, In this class, we are having a constructor again, and whenever we are creating an object of this class, we see that the constructor will be automatically called, and we need to have one argument when creating an object of this class because the constructor requires one argument, or let's say parameter, apart from self. So we are having that parameter being initialized to our attribute of the class. And also here we are having two functions, the area and perimeter. So the area is going to be the side to the power of 2. So side we decided when creating an object of the square class, side to the power of 2. This is the formula of the area of a square. And then for the parameter, we are having 4 multiplied by side. This is the formula also for the perimeter of a square. Then we are having another class called triangle. It also inherits from shape class. Square was also inheriting from the shape class. In this triangle, you see here, we are having a constructor, and this constructor requires 4 arguments, A, B, C, and height. So A, B, C are the sides, and height is the height of the triangle, and here these are being initialized to our attributes of the class. So A is initialized to the first attribute, B the same thing, C is the same thing, and height also the same thing. Then we are having the area of the triangle class. So in the area function, we are having this formula. So the height multiplied by B multiplied by 0.5. B is the side of the triangle that lays down on the horizontal line. Then we are having the perimeter, which is the calculation of this A plus B plus C. So we are having a class called triangle, a class called square, and a class called circle, and all of them inherit from the shape class. Now that we discussed the class, let us go and see how we can have numerical examples here. First of all, we would like to create our object from the circle class. In order to create an object, we write down the name of the object and it equals the name of the class, and in parentheses we put the arguments that we need for the object creation. So here I'm creating an object called circle from the circle class, and I'm passing the argument 5. Why I'm having an argument? Because in the circle class we are having a constructor and it requires one argument to be the radius of the circle. And whenever I create that object, the constructor is automatically called, and that number 5, for example, that we put there for the creation of the object is assigned to the attribute of the class. Okay, so now we created object circle from the circle class, and the radius is 5. Okay, now I can use this object circle to call the functions in the circle. Okay, let me change the name of the object. Maybe instead of circle I could have C, so it's easier to understand. So the name of my object is C from the circle class, and the radius is 5. So whenever this object is created, number 5 is assigned to the self.radius attribute of the circle class. Now using this object, I can call the area function and the perimeter function that we have in the circle class. So this is the circle class, this is the area, and this is the perimeter function. So c.area is going to call the area function in the circle class because the object is created from the circle class. When the area is called, we are using the pi number from the math library multiplied by the radius to the power of 2. What is this radius? This radius is exactly that number 5 that is assigned to the self.radius using the constructor while creating the object. So now the area is calculated we are having the colon.2f to say that, okay, only print up until 2 decimals. Then we are having the perimeter being printed, being called and being calculated, let's say, using the object C dot perimeter. So this perimeter is called 2 multiplied by a pi number being imported from the math library, multiplied by self radius, which is initialized as the class attribute using the constructor when creating the object. So we are printing all of this information. We see the circle, this is the circle, area, and area, these are the messages. And the area is calculated with 2 decimals, you see 78.54, and the perimeter 31.42. So now the circle, area, and perimeter is calculated and we see them in the output. So now we would like to create another object from another class. So now I would call this S also for the sake of simplicity. So we see that we are creating an object called S from the square class and passing the argument 4. This is the square class. We are having one argument as the side, and side is assigned to the self.side attribute of this class. Then using the same object, we are calling the area function and the perimeter function. So the area function is going to calculate self to the power of 2, self side to the power of 2, and the perimeter is going to calculate 4 multiplied by self side. Okay, so this is the square being calculated here. So the square with the side 4, the area is calculated, the perimeter is calculated, and we see it in the output. So area is 16 and perimeter is also 16. We can have another number here. So for example, we could have 5. So a square with the side 5, its area is 25, its perimeter is 20. Then we are creating an object from the triangle class. So I'm changing the name of the object as well. So the object name is T from the triangle class, and we are having 4 arguments. So A, B, C, and height. Okay, so when I go to the triangle, we are having a constructor A, B, C, and height. So these are the arguments. The first argument is assigned to self.a, the second one to self.b, etc. until the end. So we would like to create an object with these arguments with one side 3, one side 4, one side 5, and the height is 4 as well. Now, using this object, we can access the functions that are in the triangle class, in fact. In the triangle class, we are having the area and the perimeter functions. So the area function is called, we are having this calculation 0.5 multiplied by b, which is 4, multiplied by height, which is 4 again. So we see that the area is 8. Then we are having the perimeter here, which is in the output 12, and it is calculated as to be the a plus b plus c. We see that 3 plus 4 plus 5, it's 12, and it is being calculated and printed in the output. So in this video, we learned, first of all, having multiple classes inheriting from one base class, and then we learned and reviewed how to create an object from a class and access its functions. And we also reviewed that if we want to only have 2 decimals, we can have colon.2f. In the output, we want to have 2 decimals, so we are having 2f. If we want 3 decimals, we can have 3f, for example. And also we learned that whenever the object of a function and the object of a class is created, if that class is having a constructor, the constructor is going to be called automatically and initialize our class attributes. Thank you for watching. Welcome back. In today's video, we would like to write a program that defines a base class with a private attribute and provides a method to access it in a derived class using getter and setter methods. So here we are having a base class, a class called base. Here we are having a constructor, so whenever we are creating an object of this class, the value that we use for the object creation, the parameter, or let's say the argument, is assigned to our private attributes. So how do we know that it's a private attribute? Because we're having double underscores. Okay, when we are having double underscores for our attribute, it means that it's a private attribute. And the name is private attribute, but we could name it whatever we want. So whenever we are creating an object of this class called base, the constructor is automatically called, and that argument that is used for the creation of the object is assigned to our private attribute. Then in this class, we are having a function called getPrivateAttribute, or simply we call it getter function. This function is going to simply return the value of our private attribute. Okay, so when we are having a private attribute, it's important to use a getter function to access its value and use a setter function to modify its value. So this is my getter function to access the value of the private attribute, and here is my setter function by which I can update the value of my private attribute. So whenever the setter function is called, we need to pass one argument, and that argument is assigned to my private attribute. Then this was my base class. I have a class called derived, and it is derived actually from the base class, so it inherits from the base class, and it has only two functions. So the first function called show private attribute, and whenever this function is called, this message is shown private attribute value, and whenever this function is called, this message is shown, and then the get private attribute function is called, and this function was supposed to simply return the private attribute value for us. So this function, whenever it is called, this message first of all is shown. Then following by this message, it is going to call the get private attribute function, which is from the base class, and that function was supposed to give us the value for the private attribute of the base class. Okay, and whenever this function update private attribute is called, it is required to have one argument or parameter whenever we are calling this, and basically this function is going to call the set private attribute function with one argument, which is here, and assign the new value for our private attribute. Okay, so let me illustrate all of this using a numerical example. So here you see that I am creating an object from the derived class. So the object is called D. I'm creating an object from the derived class and passing number 10 as the argument. And whenever that I am passing this number 10 here, we are having the object of the derived class, and we are having one argument as 10, and whenever we are having the number 10 here, because it is derived from the base class, this constructor is called number 10, which is the parameter passed when creating the object, is here. So this is the value here, and it is assigned to my private attribute. Okay, let me review it one more time. So first of all, I'm creating an object from the derived class and passing the argument 10, because we are having an argument 10 and we don't have any constructor here. Therefore, this constructor is called, and the value 10 is assigned to the private attribute of the base class. Okay, so now my private attribute is having the value of 10. Okay, so we are here. We just finished this line. Then using that same object, I call the show private attribute function. So I can call this function because I create an object of the derived class. So this function is called. Therefore, this message is shown, private attribute value, and then the get private attribute function is called, and it is going to simply return the value for our private attribute, which was 10. Okay, so we see in the output private attribute value is 10. Okay, so private attribute value, colon. Then instead of here, we are having the number 10 being printed. Why? Because this function is called and this function is returning the value for the private attribute, which was 10. So 10 is being printed in the output. And how was it possible to have number 10 there? Because we just created an object and we passed number 10 ourselves. Then we use the same object to update to call the update private attribute function. So this function is called and number 20 is passed as argument because this function requires an argument. So number 10 is passed as argument to call the update private attribute function. Then in this function, we are calling this function again. We are calling the set underscore private underscore attribute function and passing the number 20 as the parameter. And whenever this function with the number is called, that number, which is 20 in our case, is assigned to our private attribute. So the private attribute is now being updated. Okay, we just updated the private attribute. Again, I call the show private attribute function to see if the modification is done or not. So we call the private attribute, we call the show private attribute function. This message is printed, private attribute value. Then this function is called and simply it is going to return the value for the private attribute, which is 20 now. You see it in the output because we just updated it. So in this video, we reviewed how we can define a base class and a derived class. And also we learned how we can access the functions of a base class through the functions of the derived class. And also we learned how is it beneficial to modify or access a private attribute using functions in the derived class. Thank you for watching. Welcome back. In today's video, we would like to write a program that demonstrates multiple inheritance by creating a class that inherits from two different base classes and calling methods from both parents. So here is my first class called parent1, and it has one function called showMessage1. Whenever this function is called, we are having this print message from parent1, okay? And then we are having the class called parent2, and whenever this parent2 is called, we are having a class called parent2, and this parent2 class has one function only, showMessage2. And whenever this function is called, we are having this message being printed in the output, message from parent2. So these are two parent classes, parent1 and parent2. Then we are having a class called child inheriting from parent1 and parent2, so inheriting from both parents. Then in this child class, I'm having one function that is called show all messages. And in this function, whenever this function is called, the show message 1, which is a function from parent 1, and show message 2, which is a function from parent 2, is called. So therefore, whenever this function is called, we expect to see the output of the show message 1. So show message 1 is called, and this print is showing message from parent 1. Then show message 2 is called, and this print is in the output message from parent 2. Okay, now we are creating an object from the child class, and the object name is C. And using that object, I try to access the show all messages function that is inside the child class. So when I run this code, we see that we are having message from parent 1, message from parent 2 is being shown in the output. Basically, we created an object from the child class, and using the same object, I called a function inside the child class, okay? And using that function, we were having access to the message1 and message2 functions. Why? Because the child class was inheriting from these two classes. So if it was not having any inheritance from them, when I run the code, you see that we are having an error because it's not possible for a class to have access to another class functions if they are not having any relationship with them, between them, or with them. So this child class can only access the parent classes show message1 and show message2 only if it inherits from them. So when I run the code now, we see that the output again is working. Thank you for watching. Welcome back. In today's video, we would like to write a program that defines a base class with a method and a subclass that extends the functionality of that method instead of completely overriding it. So here is my class called base. It has a function called showMessage, and it is printing this message whenever this showMessage function is called, message from base class. Okay. Then we are having a class called subclass that is derived from the base class, or let's say that inherits from the base class. In this subclass, we are having a function called showMessage again, but we are using the super function to access the show message function from the base class. Okay, so super dot show message, it is going to call the base class function show message. Then we are printing extend message from the subclass. So whenever this function is called, it not only calls the show message function from the base class, but also completes its function and do some further work. Here we are just printing this message. We can do some further work. So whenever the show message function in the subclass is called through the super function, it is going to call the show message function from the base class. Therefore, this message is shown message from the base class, and whenever the execution of this line is finished, it is going to go to this line saying that print extended message from the subclass. So this is how we can have the use of super function to call the show message from the base class. So this was the explanation. So let me create an object. So now I am creating an object from the subclass. Okay, so using that object, I'm calling the show message function, which is inside the subclass. Okay, when I run the code, first of all, we see this message from the base class. We see that this message is being shown, and then this message is being shown, extended message from subclass. Okay, extended message from subclass. So in this video, we learned that if we want to not completely override a function from the base class, we use the super function to call that show message function from the base class, and then we can continue performing whatever we would like to do. For example, we can have the print here, we can have some mathematical operations in the show message function here, etc. So we learned how to use the super function. Thank you for watching. Welcome back. In today's video, we would like to write a program that uses operator overloading to redefine addition, subtraction, and multiplication operators for custom class, demonstrating polymorphism in action. So here is my class. It is called point. It has a constructor and it requires two arguments. So whenever an object of this class is created, the constructor is called automatically, and it is going to initialize our two attributes self.x and self.y. Then we are having the overload of addition operator here, and here it is going to basically have the x plus x and y plus y. So the first one is self.x plus other.x, self.y, and other.y. Basically, the addition operator, so when we are overloading in two objects, for example, we are having two objects and we would like to create the third object using the first two objects. And each object is having an x coordinate and a y coordinate. You're going to add their x and their y. I'm going to give you a numerical example so it will be more tangible. Then we are having the subtraction overload when we are having the x minus x and y minus y. We are having the multiplication x multiplied by x and y multiplied by y. Then we are having an str overload here that defines the string representation of the for the prints when we are using the objects. So let me illustrate it with an example. Here we are having two objects being created. So the first one is P1, the second one is P2. The first one is having the points 2 and 3. So the x is 2 and 3 is y for the object P1. Okay. Then for object P2, we are having the x that is 4 and the y that is 5. Now that I'm creating the P1 object, its x and y, 2 and 3, are initialized to be attributes of the point class. Then we are having the P2, which is an object of the point class here, and it's the x and y that P2 represents. So 4 and 5 are initialized to be attributes of the point class when using the P2 object. Okay. Now I would like to create a third object using the information of the P1 object and P2 object. In order to do that, I have the object called P add, and it is equal to P1 plus P2. When it is equal to P1 plus P2, the addition overloading operator is called, and basically it is going to calculate the x and y. But how is it going to calculate? So the p underscore add needs to have a x coordinate value and a y coordinate value. Okay. In order to calculate that, the x of P1 and x is added to the x of P2. Y of P1 is added to the y of P2. Okay. So here exactly the same thing is happening. In the add overloading operator, we are having the x self.x plus other.x, okay, then self.y plus other.y. So it is going to add the x of P1 and P2 and y of P1 and P2. They are going to be calculated, and therefore the P add is going to have one x and y. Okay, so this x is calculated based on the x of P1 plus P2, and this y is calculated based on the y of P1 and P2. So we can do it only because we are using the overloading operator here. Otherwise, if I comment this part, we're going to have errors because otherwise it's not possible to add two objects to create a third object. Okay, so now that I run the code also, we see that here, for example, for p underscore add, we are having the x and y 6 and 8. 6 is 2 plus 4, which is 6, and 3 plus 5, which is 8. Okay, we did the calculation for addition. For the subtraction, we are having P1 minus P2. Again, the same thing is going to happen. The 2 is going to be subtracted from 4 and 3 is going to be subtracted from 5 using the subtract overloading operator. Then we are printing this fourth object, which is p underscore sub, and we see that -2 and -2 is being shown there. Why? Because 2 minus 4, it is going to be -2, so the x is -2. Then 3 minus 5, it is going to be -2, so -2 is being printed in the output there. Then we are having the another object, which is for the multiplication, p underscore mul, and basically it is going to have p1 multiplied by p2. So the 2 is multiplied by 4, their x is multiplied, and 3 is multiplied by 5, and their y is being multiplied. So now this calculation is done using this mul operator, and we see that, for example, x multiplied by x and y multiplied by y. Okay, so it's a coordinate wise multiplication, and also it's a coordinate wise subtraction, coordinate wise addition. Okay, so this multiplication is also calculated. So 2 multiplied by 4, it's 8, and 3 multiplied by 5, it's 15. Okay, and it is exactly what we expected here. So in this video, first of all, we learned how to use the operator overloading. We created two objects that are P1 and P2 from the point class, and each of them was having x coordinate and y coordinate. Okay, so P1 was having 2 and 3, P2 was having 4 and 5. And then we created the third object using the addition operator, and that was going to help us to have the x's being added to each other and y's to be added to each other. So 2 plus 4, it's 6, and 3 plus 5, it's 8, and this is assigned to p underscore add, and here we printed it out and we see that 6 and 8 is being there. Then we were having the subtraction, which was having the subtraction of p1 from p2. So 2 minus 4, it's -2. 3 minus 5, it's -2, is being printed in the output because we were having this line. And finally, we did the multiplication of p1 and p2. So 2 multiplied by 4, it's 8. 3 multiplied by 5, it's 15. And we are using this line to print the multiplication in this object p underscore mul. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to create a counter of the letters in a string Python exercise. So here is my string. It is assigned to a variable called text. So text is a string which holds the Python exercise string. Okay, so now I would like to count the number of letters in this string. For example, I would like to know P how many times is being repeated, Y how many times it is being repeated, T, H, O, and etc. E, for example, here, etc. So in order to do that, first of all, I import the counter from the collections. Then I use the counter function, and in parentheses, I write down the name of my string, which is text. And it is assigned to a new variable called letter counts. And in order to display the result, I use the print function and put the letter counts in parentheses. When I run the code, we see this is the output. So it says E, small e, let's say lowercase e, has been repeated 2 times. P has been repeated 1 time, for example, Y 1 time, T 1 time, etc. But we see that the E, the capital E, is also there, and it is repeated one time only. So it distinguishes between the lowercase and uppercase letters. Now I have another one, for example, here, and this, for example, we can say this is Reza Shaheen from the Python coding class. Okay, so this is my second variable, and this is the phrase, or let's say the string that I save in text2. Now letter count2 equals counter text2, and here I print the letters underscore counts2. Okay, so letter count2. So when I run the code, we see this. This is the repetition that is used in this phrase, or let's say the string. First of all, we see 8 spaces. So you see, this is the spaces 8 times. We're having 8 spaces. Then we are having H being repeated 5 times in this string. Then we are having I being repeated 4 times, S being repeated 4 times, T being repeated 3 times. So in this video, we learned that we can count the number of letters in any given string. If we want to do that, we can use the counter function, and in parentheses we write down the name of the string variable and assign it to another variable, and then print that another variable, so it will give us a number of letters that are occurring in that string. For example, here I was having the first string variable called text, and this was having Python exercise. I use the counter function, and in parentheses I put the text to count the number of letters, the number of occurrences of each letter, and assign it to letter underscore counts. And then here is when I print letter underscore counts in the output. We have E, P, Y, etc. until the end. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates a counter from a list of elements. So here is my list called elements, and there are these elements inside of this list. For example, we are having apple being repeated 3 times, we are having banana being repeated 4 times, we are having orange being repeated 2 times, and we are having the grape being repeated only 1 time. So this is the list that I have. Now I would like to count the number of occurrences of each unique element. So I use the counter function, and in parentheses I'm having the elements. Okay, so we are going to count the elements of my list called elements and assign it to elements count. Finally, I'm going to print the elements count. Now when I print the output, we see that for banana we are having number 4, which makes sense because we were having banana being repeated 4 times. Then for apple we are having number 3, so apple we see that 1, 2, and 3. Orange we see it's being repeated 2 times, and grape we see that it's there only 1 time. So this is how we can use the counter function to count the number of occurrences of unique elements. So for example, we could have another list, for example, elements 2, and there we could have, for example, pizza. So here is pizza, here is pasta, here is pizza again. I'm sorry, pizza again. We are having, I don't know, we can have burger, we can have pasta again, we can have again pizza, we can have, for example, another food that we can name here. I don't know, we could have, for example, cola, let's say cola, and we could have burger, let's say burger. And another food that we could have here, for example, again pasta, and then we could have, for example, chicken, chicken here. Okay, so this is my new list. There are some elements there. So you see that we are having pizza being repeated 3 times. We are having pasta being repeated 3 times. We are having burger 2 times, one cola, and one chicken. Okay, so it's a drink. Then here we are having the element counter 2, and we are using the counter function to count the number of occurrences of each unique element and assign it to elements count 2 and print it in the output. So we see that it says pizza is being repeated 3 times, pasta is being repeated 3 times, burger is being repeated 2 times. We are having one cola and one chicken. So this is basically how we can use the counter function to help us count the number of unique elements in a list, for example, or in a string, etc. Thank you for watching. Welcome back. In today's video, we would like to write a program that creates a food name tuple. Why do we use name tuples? So they provide immutable and lightweight structures like tuples, but with named field. So it's better for readability of the code. And also it improves the readability but allowing access via names like food.name instead of indices like food, and we are having the index 0. So it's more readable and understandable to anyone that food.name means what. For example, we're talking about the name of the food, but instead food with the index 0, we need to think, okay, what was the name that we put, what was the name of the food that we put for the first index, for example. So it's more readable, okay, this way. So now here, in order to use the name tuple, we need to import it from the collection module. And here we are defining a name tuple for food. So each name tuple is going to have a name and a price, and the name of the name tuple is food that we are having it here in my code in this line. And this is the keyword for name tuple. So whenever we want to create a name tuple, we need to use this keyword. Then we are going to create a dictionary with food names as keys and food name tuple as values. Okay. So here the name is burger, for example. The name is pizza, pasta, salad, and sushi. And we see that different prices are there. So different prices. For burger, we are having the price 5.99. For pizza, we are having the price 8.99. For pasta, we are having the price 7.49. Again, for salad, we are having the price, and for sushi also, we are having the price here. So this is a name tuple that we are having here. So the food names are the keys and the prices are the values that we are seeing it here, okay? So here we created the name tuple with names and prices, and here we are creating a dictionary with different food names here with their corresponding prices. Then we are having a for loop. So we are iterating through the food menu dictionary. In order to iterate through food menu dictionary, we know that in dictionaries we are having key value pairs. So food menu dot items will help us, the items function will help us to go through that dictionary with the key value pair. So food name is going to take the name, which is the key, and food info is going to iterate through the values. So food name is going to iterate through the keys, which are burger, pizza, pasta, salad, and sushi, and food info is going to iterate over the prices. So 5.99, 8.99, etc. until 12.99. So this is the iteration. So for example, in the first iteration, we are going to have the key equals to burger, and here we see that value equals to 5.99. So it means that in the first iteration, food name equals the burger and food info equals $5.99. Okay. Then in the second iteration, instead of having the key, I'm going to write down food underscore name. This one equals pizza. Okay. And instead of value, I'm going to write down food info because they are our iterating variable. So, and food info is $8.99. In the third iteration, we are having again the food name. This time it is pasta. And then the food info equals 7.49. Fourth iteration, we have the food name equals sushi. Then food info equals $12.99. Okay, so this is what happens in different iteration here. So in the first iteration, we are having the burger. Then we are having the pizza. Then we are having the pasta. Then we are, okay, I missed the salad. So the fourth iteration is salad. This is the fifth iteration for sushi. Yeah. So fifth iteration, fourth iteration, food name equals salad. And then the food info equals 4.99. So the fourth iteration, this is a salad and its price, and then sushi and its price. So we learned here that we are iterating through the food menu dictionary using the items, meaning that we are going to go through the key value pairs, and this is the iterating variable for keys, food name, for example, pizza, pasta, salad, sushi, burger, and food info, which is the value that is for $5.99, $8.99, $7, etc. until the end. So when I run the code in the output, we see exactly what we estimated here. In the iteration, in each iteration, we are printing the food name and its price with a dollar sign. For example, it's $5.99. So we see that in the first one, we are having the burger, then pizza, pasta, salad, and sushi exactly as we expected. So this is how we can have the access to the names and also to the prices. And it's very good that we are using the name tuple because we are having the, for example, food.name instead of having the index 0, meaning that, okay, we need to remember the name of the food is stored in the index 0. And when you're having like hundreds of lines of code, it's very hard to remember which dictionary or list was having the food name, for example, in which index, etc. So it will become very complex. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that defines a named tuple with fields like name, age, and marks. And for the marks, we would like to have a list of subjects and marks. So here we see that we are having a class called student, which inherits from named tuple. So in Python, when defining a class that inherits from named tuple, the class itself acts as a structure immutable tuple. For example, writing a class student here with the inheriting from the named tuple means student inherits from named tuple, automatically gaining tuple-like behavior without needing an explicit constructor method. So we don't need to have a constructor here when we are having the inheritance from the named tuple because it is going to automatically gain the tuple-like behavior. So here is my class. I have the name, age, and marks. And the name is a string. The age is going to be an integer. And we are having, for the marks, we are having the list as we were asked to. So a list of subjects and marks. So we are having the list. And here is the subject and marks, so a string, and also the marks as an integer. So a string is for the subject. So it is going to be a list of tuples containing subjects and marks. Okay, a list of tuples that contains subjects and marks here. Okay. So now I would like to create an object of the student class, and here is called student1. So student1 is the name of my object, which is created from the student class. And because the student class inherits from a name tuple, we need to have these information in parentheses. So the name, age, and marks. So name is there, Alice, it's a string. Then age is there, we're having 20 as the integer, and then the marks is there. And we said for the marks, we're having a list of tuples. So a list of tuples, for example, math 90, this is one tuple. This is the second tuple, science 85, English 88. Okay, and all of them are in a list here. Okay, a list of tuples. So we created the student1 object with all these information, and we see that here, if we want to print the details, we can see the student1 dot name to access the name, which is Alice. Then we can have student1 dot age to access the age, and student1 dot marks to access the marks. So in the output, because we are using the print function here, we can see the student details, this message. Then the name is Alice, age is 20, and marks, you see that math 90, science 85, and English 88. And we can have another, for example, object from the student class, student. We can have the name, for example, to be equal to Bob. The name equals Bob, age is 22, marks, math is 85, science is 92, and English is 89. Now if I want to print the information for the Bob, we can simply print here the student details, and then we are having the age student2 dot name. This time we are using the second object because we want to access the Bob's information. Then we are having the student2 dot age student2 dot mark. So when I run the code, we see that the student details again, Bob age is 22, and the marks are math 85. Then we are having the science 92. Then we are having English, which is 89 here. So in this coding exercise, we learned how to have a class that inherits from named tuple library. And there we are having this information like the name, age, and marks. And marks is a list of tuples. We see that it's a list of tuples. So one tuple, the second tuple, the third tuple, etc. until the end. And then we created different objects for different students to store different information of each student individually. So we see that then we using the first object, we can access the name, age, and mark. We see them in the output. Using the second object, we can access the name, age, and the mark as well. So in this video, it was a good example to review name tuple and student and a class called student, and use a class in Python to inherit from the named tuple. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates an ordered dictionary and adds some items. We would like to, in the end, print the ordered dictionary content. In order to use the ordered dictionary, first of all, we need to import this library from the collection module. Then here is how we can create an ordered dictionary. So now I am creating an ordered dictionary called ordered dictionary. And in order to create it, we need to assign it to ordered dictionary function with empty parentheses. So on the right hand side, I'm having ordered dictionary, function, and on the left hand side we are having the name of our ordered dictionary. So the name of our dictionary could be anything. It could be, for example, my dictionary. For example, we could have it like this, and now I need to replace it everywhere else here. Okay, so now the name of my ordered dictionary is my dictionary, and in order to create that, I'm using the ordered dictionary function. Now I would like to add some items to my ordered dictionary, and we know that because the dictionaries are key value pairs. Okay, so whatever we are going to have in our dictionary, it is going to be like the key and then the value. Okay, another key, another value, etc. Okay, so now if I want to add items to my ordered dictionary, we should have the key and its associated value. Now, in order to add a new item, I'm writing down the name of the item, the name of my dictionary, sorry. So my dictionary is the name of the dictionary, then the name of the item. On the right hand side, we write down the name of the value. So here now I am adding apple. So apple, and we are having number 3 as its associated value. Okay, so this is apple is the key and 3 is its value. So we are having the key apple and value 3 being added to the ordered dictionary called my dictionary. Then we are having this line, so we are having the banana here, and we are having number 5 being added to it. Then we are having another key called cherry, and its value is number 2. Then we are having the date, and its value is 7. So we see that we are adding these keys with their associated values to my dictionary. Okay, so this is my ordered dictionary after doing all of these addition that we did here. So here we learned how we can add keys and the associated value to my dictionary, which is an ordered dictionary. Okay, so now if we want to print the content of my dictionary, I show this message saying that ordered dictionary content, and this is it. Then because we are having a dictionary which has key value pairs, we are going to have 2 iterating variables. So the variable key is going to iterate over the keys, which are apple, banana, cherry, and date. Then the value, which is another iterating variable, is the variable that iterates through the values 3, 5, 2, and 7. Okay, so the key is going to iterate over the names here, and the value is going to iterate over the values. So for each key and value in my dictionary, because we are using the key value per iteration, we use the items function to make it possible to have the key value pairs iteration. So for each key and value in my dictionary, we use the item function to iterate over them, and then we are having simply the key in each iteration and its associated value. So in the first iteration, for example, we are having the key to be apple and its value is 3. Why? Because we added the first apple and then its value is 3. Okay, so this is what we added. Then we are having the second iteration. Then we are having banana and number 5. Okay, in the third iteration, we are having cherry and number 2. In the fourth iteration, we are having date and number 7. Meaning that, for example, we are going to have 3 apples, 5 bananas, 2 cherries, and 7 dates. Okay. So, and we know that in ordered dictionary, it can, when we have an ordered dictionary, it can remember the order in which we inserted the data. and the keys and the values. This is why when we are inserting first apple, apple is the first key in our order dictionary, and its associated value is 3. Then we inserted banana, so banana is the second key with its associated value in our order dictionary. So we see the order dictionary in the output here as well. So in this video, we learned how we can create an order dictionary, insert items with their associated value to our order dictionary, and also we learned how we can iterate through an order dictionary for the key value pairs. Also, we reviewed that we know when we are working with order dictionary, they are going to remember the order in which we insert the key value pairs. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that assesses an item in the order dictionary by its key. And we would like to check if a specific item exists in the order dictionary as well or not. So first of all, we're going to import the order dictionary from the collection module. Then here is the creation of my order dictionary. So we are having an order dictionary called order dictionary. And we can change the name for the sake of simplicity. We can say, for example, ordered dictionary 2, for example, just for the sake of simplicity. And we can give it any name that we want. It's not an issue. So I create an order dictionary using the order dictionary function, and the name of my order dictionary is order dictionary 2. Then it has certain keys with associated value. For example, we're having apple with the value 3, we're having banana with the value 5, we're having cherry for the with its value which is 2, and we're having the date with its value which is 7. So 4 keys and the associated value. Then in order to access an item by key, we can say, for example, we see that banana is already there. We are having a new variable or a string called key to access, and it is assigned to banana. Banana is assigned to this key to access variable. We would like to check to see if this key to access, which is banana, exists in the order dictionary 2 or not. So we write down if key to access in order dictionary, or in other words, we can say if banana exists in our order dictionary. If so, if this statement is true, print this line for me. The value of the key to access, which is banana, the value of banana is, and in order to understand its value, we are going to write down the name of the order dictionary and the name of the key. Okay, so here we are saying that the value of banana, because banana equals key to access, is, then because we want to extract its value, we're going to write down the banana from the order dictionary 2, so it is going to give me its value. So when we see the output, we see the value of banana is 5. So we see that we are having 5 bananas here, and we are accessing it here easily. So we check first of all to see if that key to access, which is banana, is in the order dictionary. If so, we simply the value of banana is, then here we are going to execute it and access its value. So the value of banana in the order dictionary 2 is being printed. And if the key is not in the dictionary, we are going to say this message. We are going to print this message simply saying that that key to access is not found in the order dictionary. For example, if we are talking about, for example, pineapple, and we don't have the pineapple here, you see, and key to access equals pineapple now, and then we are checking to see if pineapple is in the order dictionary. Is this sentence true? No, it's not true. Therefore we go for the else part and we write down pineapple is not found in the order dictionary. So pineapple is not found in the order dictionary. But if there is something that is already there, this statement will become true and this line is executed. Then we would like to check if a specific item exists or not. For example, here we can say this in this line we were trying to check if an item exists. If so, I would like to know its associated value. But here we simply want to just check to see if grape already exists in the order dictionary true or not. So we check here if grape is in the order dictionary too. If this statement is true, we don't have the grape here. But if this statement is true, we are going to print this message saying that grape exists in the order dictionary. Else, we are going to say grape does not exist in the order dictionary. Okay, so we are going to say if grape is in the order dictionary. Is this a statement true? No, it's not true because grape is not there. We are only having apple, banana, cherry, and date. Therefore, this statement is not true. We go to the else part, and here we are going to have this message. The grape does not exist in the ordered dictionary, which is exactly the message that we are having here. Grape does not exist in the ordered dictionary. So this is how we can also check to see if, for example, certain item exists in our order dictionary or not. Then in order to have all the items of the order dictionary to be printed, we can simply use a for loop. So for each key and value in the order dictionary, we're going to use the items function to access an iteration for both keys and values in the order dictionary too. In each iteration, we are going to print the key with its associated value, which is apple and 3, banana and 5, cherry and 2, and date and 7. So in this video, we learned that how we can check if an item exists or not, and if so, how we can have access to its value. Also, we learned that how we can have an iteration over the key value pairs in our order dictionary. And here we see that the key and value in each iteration is being printed. For example, in the first iteration here, key equals apple, and we are having the value equals 3. Okay. So key equals apple, value equals 3. Then we are having key equals banana, its value is 5 in the second iteration, third iteration, and finally the fourth iteration. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates two counter objects and find their union, intersection, and difference. So in order to work with the counter, we are going to import the counter from the collection module. Then we are having two counters here being created. So two counter objects are being created here. The first one is called counter1, and it has 3 apples, 6 bananas, and 5 cherries. And in the counter2, we are having 1 apple, 4 bananas, and 2 dates. So this is what we have here. Then this is what we were required to do. So create two counter objects. Then we would like to find their union. So this is the first thing that we are asked to do. In order to find their union, we need to write down the name of the first counter, which is counter1, then pipe operator, then counter2. So this is going to calculate the union, and they're assigned to union counter. Okay. So this way, for the union, we are going to have the maximum count of each element. Let me go to the results. So first of all, we are printing counter1 and counter2. So this line is counter1, this line is counter2. So we see here 3 apples, 6 bananas, 5 cherries, 6 bananas, 5 cherry, and 3 apples. And we see that 1 apple, 4 bananas, and 2 dates, 4 bananas, 2 dates, and 1 apple. So counter1 and counter2, they are being printed here. Okay. Then we are having the union counter being printed here that we created here using the pipe operator. So it is going to return the maximum count of each element. The union counter, we see that here we are having the maximum count of each element. So Banana, we are having its value 6 because we are having two bananas, one 6, one 4. So the maximum is the 6. So we are going to report banana 6. Then we are having cherry, which is 5. Then we are having the date, which is 2. And also apple, which is 3. So among all these elements, we're going to report the maximum. Cherry, what is the maximum? We are only having one cherry. I mean that the cherry is only in counter 1, it's not in counter 2, and the maximum is the 5. So we are having 5 cherries. This is why we are reporting it here. Regarding the date, do we have any other dates here in another counter? No, so the maximum number is 2. And with respect to banana, we are having 6 bananas and 4 bananas in counter 1 and counter 2. So we are going to report the 6 bananas, which is from the counter 1 because we report the maximum count of each element. And also with respect to apples, we are having in both counters, we are going to have 3 apples, which is here, and it is coming from the counter 1. So this is how we are calculating the union. So basically for union, we are going to use the maximum count of each element. So this is union. Now we would like to discuss the intersection. Now that we would like to discuss intersection, we can have counter 1 and operator and then counter 2. Okay, so counter 1 and operator counter 2 in order to calculate the intersection, and it is assigned to intersection counter. Basically, it is going to calculate the minimum count of each element. So intersection is being printed here. We see that here when we are having the intersection counter, the minimum count of each element is shown. So banana, we are having 6 and 4. So what is the minimum? It's 4 bananas. So 4 bananas is there. We are having apples that is shared between both counters. So we are having 3 apples and 1 apple. So we are going to have 1 apple only. One thing that we need to be careful about with the intersection is that we are going to discuss the elements that are shared between both counters. And now this is why we don't have cherry and date in the output, because they are not shared in both counters. Only banana and apple are shared, and we are going to report the minimum element. So banana 6 and 4, we are going to report 4. Apple 1 and 3, we are going to report 1, because in intersection we are working with the minimum count and we see it here. Okay. And finally, they were asking us to have difference as well. So we are going to have the difference. So it means that elements that are in counter 1 but not in counter 2. So we are having the difference counter 1 minus counter 2. So counter 1, we are having 3 apples. Here we are having 1 apple. So 3 minus 1, it will be apple that it will result in having 2 apples. We are having 6 bananas and 4 bananas. 6 minus 4, we are going to have 2 bananas. And finally, we are having cherry that is in the first counter and not in the second counter. So we are going to have cherry in the output as well. So in this video, we learned how to create 2 counter objects that we are having it here. And we reviewed about finding their union, intersection, and difference. We learned that if we are working with unions, we need to use the pipe operator. If we are working with intersection, we are going to use the AND operator. And if we are working with the difference, we are going to have the subtraction sign or operator. And something to mention here is that the elements that are in counter 1 but not in counter 2 is going to be calculated like this. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates a counter of the vowels in the word Python exercises. So here is my phrase, here is my string. It is called phrase, and we are having this string Python exercises. This Python exercises is assigned to the phrase string, Then we are calling the count vowels function and passing that phrase as the argument. So when the compiler sees this code, it is going to call the count vowel function and start executing it. So first of all, we are having the vowels here. We are defining our vowels both in uppercase and lowercase. Then we are having our counter being initialized to be 0 because we are going to count how many vowels are there in this phrase. So the counter is initialized to be 0. So in the beginning, we assume that there is no vowels inside this string, but we are going to check and update the vowels using for loops. So now our phrase that is holding our string, okay, Python exercise is a string assigned to the variable called phrase. That phrase is passed as argument to the count vowels, and here we call it word. We can call it whatever. So we are iterating that word for each character that is inside that word, meaning that there are different characters. So in the first iteration, we are having, for example, in the first iteration, we are having P. In the second iteration, we are having Y. In the third iteration, we are having a T. In the fourth iteration, we are having H, for example, etc. until the end. So in each iteration, we are going to move character by character from our string P, T, H, O, N, E, X, E, R, C, I, S, E, and S. So these are the characters we are going to loop through, character by character that is inside this word string. Okay, so and we are going to check in each iteration if character is in vowel or not. So in the first iteration, we are having the P, and we check to see if P exists in vowels or not. P, is it there? No, it's not there. Because it's not there, nothing is going to happen. Therefore, this counter is not going to be increased. So we go for the next iteration. Then we are having the Y in the second iteration. So here in iteration, we are checking to see if, for example, Y is in the vowels or not. So in the second iteration for the for loop, we are having character, which is Y, and we check to see if Y is inside the vowels. Is it there? No, it's not there. We go up. Then we are having the third iteration, which is T here, okay? So T we check to see if T exists here. No, it's not. We go up again, we go for the next iteration. Then we are having the H. We check to see if H is there. No, it's not there. Then the next character in the fifth iteration is O. So we check to see if O is there. Yes, O is there actually. In the fifth iteration here, we are having the O. And here we check to see if O is in the vowels. Okay, is it there? Yes, it's there. So we are having the lowercase o here and we are having the lowercase o here. So it's there. So this statement is true and we are going to increase the counter. So now the count equals 1 after this update. So we go up again, we go for the next iteration. We are having N. N, is it there? Is it in this vowel? No, it's not there. So we are going to repeat, etc. until the end. And in each iteration, we check to see if any of the characters here is already inside this vowel strings or not. So for example, here we are having the E. We check to see if E is in vowels. Yes, it's in vowels. So we are going to increment the count. And whatever the output of this function is, we are going to have the count. So as the output of this function, after doing all the iteration, we are updating in each iteration the count, and we are going to return the count here in the count vowels function. Okay, the count vowels function, we are going to have the return of the count. So it is going to count how many vowels do we have in our string. And this was the place where we called the count vowels function, and the output of this function, which is the counter, is going to be assigned to vowel count. And finally we are printing the vowel count, and we are saying that the number of vowels in our phrase here, the Python exercise, is 5. We could have, for example, the shorter uh, string. For example, we are having Reza here. So when I run the code, we see that the number of vowels in Reza is 2, because we are having one E and one A. So in this iteration, we are looping through all the characters in this string, which is REZA. So R is not there, E is in the vowels. So E in the next iteration, we see it's in the vowels. So we increase the counter to 1. Then Z, is it in the vowels? No. So we are going for the next iteration. Then in the next iteration, we are having A. A is already in the vowels, and therefore we are going to increase the counter one more time. So basically this function is work in a way that we are having a string called vowels, and we are having a counter initialized to be 0. We are going to loop through the character of this string. So we are going to character by character, and we check to see if any of the characters in our phrase is inside the vowels string or not. If it's inside there, we are going to increment the counter by 1, meaning that we found one vowel in our string. Otherwise, we are going to go for the next loop, etc., until the end. And finally, in the end, we are going to have the count variable, which has a number representing the number of vowels that we have in our code. Thank you for watching. Welcome back. In today's video, we are going to have an inheritance with a school system with teachers and student. Here is my base class called person. In this class, we're having a constructor, and in this constructor, there are 2 arguments, name and age. And basically, whenever we are creating an object of the person class, we need to pass 2 arguments, and these 2 arguments are going to be used to be assigned to the attributes of our class, which are self.name and self.age. Also, in the person class, we are having a function called display info. And whenever this function is called, basically it is going to show the name attribute and the age attribute. Then we are having a derived class, or a child class, let's say, called student from person. So it inherits from the person class, or it's derived from the person class. So person class is a base class for the student. Here we are having a constructor, and for this constructor, we are having 3 arguments, name, age, and student ID. So whenever we are creating an object of the student class, the constructor is going to be called automatically, and 3 arguments are needed to create an object from the student class. We're going to have some exercises with respect to this, but first of all, I'm explaining what's happening in my code. So we need 3 arguments, name and age and student ID. So we are going to have the student ID being assigned to the attribute self.student ID. However, with respect to the name and age, we are going to use the super function to call the constructor of the base class. Okay, when using the super function, we are able to call a function from a base class, from our base class. So I use the super function to be able to call a function from the base class, and that function is my constructor. So I'm calling the constructor of the base class using the super function and passing 2 arguments, name and age. So the name and age that were passed as arguments when creating an object of the student class, they are going to be used to call the constructor of the base class with these 2 variables, arguments, and these 2 are going to be assigned to the attributes of the function. So whenever I'm creating an object of the student class, the constructor is automatically called. We need 3 arguments. The first 2 arguments are used to call the constructor of the base class using the super method. And there we explained that the name and age are going to be used to uh, be assigned to the attributes of the function. And the third argument here is going to be assigned to the argument of the person class, which is student ID, self.student ID. Also, we are having a function here called display info. And whenever this function from the student class is called, it is going to say student name and then show the name, the age, and the ID. Finally, we are having another derived class called teacher. It inherits from the person base class. And whenever we are creating an object of the teacher class, again, the constructor is called. It needs three arguments, name, age, and subject. Again, name and age, the first two arguments are used to call the constructor of the base class person using the super function. Without super function, it's not possible. So we use super function to be accessible. So we can access and call this constructor of the base class. And then the third argument, which is subject, is assigned to our attribute here. Finally, we are having a function here called display info. And whenever this function from the teacher class is called, it is going to show this message: teacher name, age, and subject. Okay, so this was an overview of what's happening inside my three classes. One of them is the base class. The other two are the derived class, or let's say the child class. Then we would like to create our objects. So first of all, I'm creating an object called student from the student class. So student is the name of my object on the left-hand side, and this one is the name of the class. And as we discussed, we are having three arguments: name, age, and student ID. Why three arguments? Because we mentioned that here, because we are having a constructor in the student class. Apart from self, we are having three arguments. Sorry, three arguments we are having here. And therefore, these three arguments are required when creating an object of the student class. So Alice 20 and a student ID is passed. Alice and 20, name and age, are used to be called the constructor of the base class using the super method. And whenever this is called with two arguments, these two arguments are assigned to the attributes of the class. Okay. And the third argument, which is the student ID, and the student ID, when it is used, so here is the student ID and here is my student class. So a student ID is passed as the third argument and it is assigned to the self.student ID attribute of the class. So now I created an object. The constructor automatically was called from the student class, and all the initialization have been done. Now I want to create an object from the teacher class. So the name of my object, which is written on the left-hand side, is teacher. And from the teacher class, and we are having three arguments here as well: name, age, and subject. So Mr. Smith and 40, the name and age, are used to call the constructor of the person class, the base class, using the super method. So Mr. Smith and age are initialized to our attributes, are assigned to our attributes. And the subject, which is mathematics, is assigned to the self.subject attribute of the teacher class here. Okay, so now we created two objects of two different classes, one from the student and one from teacher. Now we would like to access this information and see the information in the output. This is why we are having the display info functions in our classes. So I use the first object, which is a student dot display info, to access the display info function from the student class. Then we are having the teacher object, which is my second object, to call the display info function from the teacher class. So basically, and we are calling them inside a print function. Therefore, we are going to see them in the output. So we see that here we are having the student name Alice 20, and this is the ID. And we are having the teacher name Mr. Smith, the age is 40, and the subject is mathematics. So in this video, we first of all reviewed the concept of classes, derived classes, or let's say the child classes or inheritance, we can say that. And then we also reviewed how We can benefit from inheritance and use the super method to access a function that is inside the base class. And also we reviewed how we can create an object of our classes and use them to have access to the functions inside the classes. Thank you for watching.